Okay, we're going to talk about a couple of theorems here, or postulates, about angles and circles or circumferences. So one that we're going to talk about is just a pretty basic one, and that just says that if you have a central angle, whatever measure the angle is, the arc that's associated with that, so where the angle intercepts the circumference, the arc that's formed, is the same measure. So if this angle here is 20 degrees, if that angle is 20 degrees, then the measure of this arc here is also 20 degrees. Okay? And if, conversely, if this measure of this arc, let's say, is 30 degrees, then the measure of this angle here would be 30 degrees. So these two measures are exactly the same. One is the angle measure and one is the arc measure. Okay, so for a central angle, if we have a given measurement, the arc that is intercepted by the angle is going to be the same value. Okay. Now, for an inscribed angle, it's a little different. For an inscribed angle, we're going to pretend that this actually all the way intersects here. So if this angle here is 20 degrees, then the arc is going to be twice that measurement. So this arc is going to be 40 degrees. So when an angle is inscribed, the vertex is on the circumference, and the angle intercepts this circumference of the circle here at this particular angle, or arc, sorry. And so this arc here is going to be, the measure of this arc is going to be twice the measure of the inscribed angle. Okay, so that's for an inscribed angle. Okay, so we can look at a couple more of those. If we have a circle here, and we have this angle here. Oh, no, we're going all the way. So we've got, this is actually a really great one. So we've got this going through the center, and we know that because I drew a center point. And we have this angle here, and then let's actually draw an inscribed triangle. So this is a great one for us to talk about, an inscribed triangle. And let's say that this is X, and this is Y, and this is Z. And we see here that XZ is a diameter. Okay, so the angle here, this angle Y, this angle here, intercepts the circumference at XZ, And so the arc that's formed, we know this arc that's formed has a measure of 180 degrees. And we know that because XZ is a diameter. And so it's cutting the circle in half. And a whole circle measures 360 degrees, so half the circle would be half of 360, or 180 degrees. So I know that this arc measures 180 degrees, and that arc corresponds to angle Y. And so because it corresponds to angle Y, I know that this angle here has to be 90 degrees, because it has to be half of the arc that's formed with the interception. So it has to be half of that angle. So we've got 180 divided by 2 is 90. So that's why this is a right angle. Okay. Let's look at a question that we're given. Let's see. This is just one from one of your worksheets, but let's see. We can let it be anything. Let's let it be something a little more challenging. Let's do this angle here given is 94 degrees. Let's say that this arc from here to here, this arc here is 92 degrees. We're going to name these X and Y, and this down here is C, and this is W. And we want to know what this angle here is. Okay, we're also given that this arc down here is 60 degrees. Okay, so one place to start, and it's a great place to start, is by looking at the angle that's given. And the angle given, the inscribed angle we have is 94. So we've got this angle here. Let's fatten that up a little. We've got this angle here. Okay, and that angle is 94 degrees. And so what we know is the arc that is formed by these interceptions, so this arc right here, has to be 94 degrees times 2. So 94 degrees times 2. And 94 times 2 is 188 degrees. So this part in red is 188 degrees. Well, what we know is that this piece from W to C is 60. And if W to C, arc WC is 60, and we know that from WCY is 188, so this is what we know. We know that arc WC is 60 degrees, and we know that arc WCY is 188 degrees. We can say that arc WC plus arc CY is equal to arc WCY. So we can figure out what this arc CY is. We would subtract 60 degrees from each side, and we can find out that X, or our unknown arc, is equal to 128 degrees. So from C to Y, we know is 128 degrees. Now all the way around a circle is 360. So this last piece over here, this arc WX, we can find arc WX by saying the total, right? We know that the total is 360 degrees. And so that has to equal all of these smaller pieces. And right now we know that we've got 92 degrees and 128 degrees and 60 degrees. And then we have this arc WX. Okay? And then we have arc WX. And we need to find out what WX is. And so we can simply add all of these numbers together and subtract it from 360. And when we do that, 92, and that's 100, so that's 120, and 60 is, so that's, sorry, I can't do anything in my head, 220, and 60 is 280, and so I can find this angle here by saying 360 minus 280, and I would get 70. That's not right. I would get 80. Okay, so I would get that this angle here, or the arc measure, sorry, it's not an angle, the arc measure is 80 degrees. Okay, so now what I'm looking for is this angle right here. And so I'm going to pick a different color. And I'm looking for this angle right here. Okay. So what I know is that this angle here is equal to 1/2 the measure of the arc. I know this is equal to 1/2 the measure of arc, the measure of arc X XWC. Okay, so arc XWC can be found by saying 80 plus 60 is 140. Okay, so this isn't actually, should be 3 letters. It's a minor arc and not a major arc, but it would be 1/2 of arc XC, where XC is 140 degrees, so my angle measure would be 70. So the missing angle is 70 degrees.